These are the practice problems for lesson 7. And lesson 7 is on similar polygons. It's problem number 1. It says that you have triangle DEF is a dilation of triangle ABC with a scale factor of 2. In triangle ABC, the largest angle measurement is 82 degrees. What is the largest angle measure in triangle DEF? And it gives you some possible answers: 41, 82, 123, 164 degrees. The answer is 82 degrees because all the angles in similar figures are congruent. So if it's the largest measure, if it's the angle with the largest measure in one triangle, then in a similar triangle, it's still going to be the angle with the largest measure. They are congruent, so they all have the same, all the angles have the same size. Number 2 and 3, I really had trouble with these problems. It says, number 2, draw 2 polygons that are similar but could be mistaken for not being similar, and explain why they are similar. I just had trouble doing it. And so I decided, well, I'll do a reflection, and then I'll do a little rotation, and then maybe dilate it a little bit. If I reverse those, I'll get back to the original, and they are similar figures. And does this look like it's similar to this figure? 2 polygons that are similar but could be mistaken for not being similar. So could these be mistaken for not being similar? And I think so. So you just have to play around with it a little bit. Usually if it involves a reflection and a rotation of some sort, they become hard to distinguish which are similar and which are not similar, if they're close, of course. Problem number 3 said, draw 2 polygons that are not similar, but could be mistaken for being similar. Explain why they are not similar. So what I did in this one is I just changed one of the angles a little bit. I just stretched this angle out like this, and if I had dilated this probably larger, maybe smaller compared to this one, they might look very similar. It might be hard to tell that this angle, in fact, is a different angle than this angle. I didn't really like these 2 problems, but that's okay. Number 4. These 2 triangles are, actually this is additional number 3. And so what I did is I tried a rotation and then a reflection. So these are similar, but then what could I do to make them not similar but still look like they're similar? And so I decided, okay, I will change the sizes a little bit. The overall look is the same, but then you start looking closely. This vertical side goes all the way up to here. This has been moved over a little bit. This is a reflection. So this angle is the same as this angle down here, but this goes up vertically, but then it cuts into this side. This goes up all the way vertically. So I just made a couple tiny changes, and at a distance, they still look like they are similar, I think. Again, it's the reason I didn't really like these 2 problems. Okay, the next one. These 2 triangles are similar. It says find the lengths for A and B. So here's A right here, over here, and here's B. Find those 2 lengths if these 2 triangles are similar. So I lined them up so that their corresponding sides are in a similar position as you look at them. There always has to be a key to solving a problem like this. There has to be one pair of these corresponding lengths has to reveal what the scale factor is. And that is right here. So 3 times 3 is equal to 9. So that tells you that the scale factor is 3. So then A times 3 is going to equal 21. So what is A? So A times 3 equals 21. A is going to equal 7. So 3 is the scale factor. 3 times 7 equals 21. And in this one, 5 times 3, the scale factor equals 15. So B up here is equal to 15. But the point is that there must be a relationship that shows you the scale factor. So when you have this kind of problem, just carefully go through each corresponding side and find the relationship where you use a factor to get from one corresponding side to the other corresponding side, and that will be the key to solving the problem. What are some ways that you can convince Jada that her claim is not true, that these, let's see, Jada claims that B prime, C prime, D prime is a dilation of B, C, D, B, C, D, with the center of dilation at A. So how can you convince her that this is really not a dilation? Because if you draw lines through the corresponding points and the center of, this should say center of dilation, it says center of reflection, and the center of dilation, not reflection, they line up. They look like it looks like B prime, C prime, D prime is a dilation of B, C, D, and that this triangle up here looks very similar to the larger quadrilateral. Actually, this quadrilateral up here looks very similar, if not similar, to this quadrilateral down here. But then you have to check the scale factor, and then you have to check the angles. So check the size of all the angles must be the same, and there must be a proportional change. So if this is the quadrilateral you're starting with, each length must increase with the same scale factor. Well, one of the things to check is the angle. So if I just copy this angle and translate it, move it down here, is this angle down here the same? Oops. And no, it's not. So this angle down here is different than this angle, B prime, C prime, D prime. So these images are not similar. It's not a dilation. This quadrilateral, the larger quadrilateral, is not a dilation of the smaller quadrilateral. And if you check the number of times that each length is increased, this one is going to be increased more times than this one. I didn't actually figure that out, but you can actually tell just by looking at it now that you know that it's not a dilation. All right, the last problem says draw a horizontal line AB, then rotate the segment AB counterclockwise around A. So I'm going to rotate that segment counterclockwise around A. Then it says rotate the same segment clockwise around B, 90 degrees, by the way. So 90 degrees and 90 degrees. And describe a transformation on segment AB you could use to finish building the square. So what you could do is just translate AB straight up, the length of AC, the length of, I guess this would be BA, if this takes A up here. And so translate AB that length, and that will complete the square. So this finishes the problem set for lesson 7.